Hi, sir. My maths concept period topic. My name is T. Chitretti. Roll number is 70 from branch CSCB. My maths concept period topic is unitary matrix. So let's start. So what is unitary matrix? Unitary matrix. A unitary matrix is a matrix whose inverse equals to its conjugate transpose. Unitary matrices are the complex analog for real orthogonal matrices. If U is a square complex matrix, then the following conditions are equivalent. So basically, the unitary matrix is a matrix which inverse is equal to transpose matrix. So I mean conjugate transpose matrix. So U is unitary. The conjugate transfer U star of U is unitary. U is invertible, and U inverse is equal to U star. The columns of U form an orthogonal basis with respect to inner products determined by U. The rows of U form an orthogonal basis with respect to the inner product determined by U. U is an isometry with respect to the inner product determined by U. So what is unitary matrix formula? A complex matrix U is a unitary if U star is equal to I. Notice that if U happens to be a real matrix, U star is equal to UT. And the equation says UU2 is equal to I. That is, U is orthogonal. In other words, unitary is the complex analog of the orthogonal. What is unitary matrix with example? A complex conjugate of a number is the number with an equal real part and imaginary part, equal in magnitude but opposite in sign. For example, the complex conjugate of x plus iy is x minus iy. If the conjugate transpose of a square matrix is equal to its inverse, then it is unitary matrix. The basic definition of unitary matrix is if the conjugate transpose of square matrix, the conjugate transpose of square matrix is equal to its inverse. The conjugate the conjugate transpose of a square matrix is equal to its inverse, then it is unitary matrix. The conjugate transpose of a square matrix is equal to its inverse is unitary matrix. So here is the unitary matrix example. Example 2. The unitary matrix. Show that the following matrix is unitary. A is equal to 1 by 2, given square matrix 1 plus I, 1 minus I, 1 minus I, 1 plus I. So A into, so we know the definition of unitary matrix is the definition of unitary matrix is the conjugate transpose of a square matrix is equal to its inverse. Conjugate transpose of a square matrix. So A star is equal to 1 by 2 into 1 plus I, 1 minus I by 1 minus I into 1 plus I into 1 by 2 square matrix 1 minus I, 1 plus I, 1 plus I, 1 minus I. We'll get 1 by 4 into 4, 0, 0, 4. We'll get I2. We conclude that A star is equal to A inverse. Therefore, A is a unitary matrix. So, we know the definition that the conjugate transpose of a square matrix is equal to its inverse is unitary matrix. So, the given problems, the solution of the given problem satisfies the definition of unitary matrix. So, hence, the conjugate transpose of a unitary matrix of a square matrix is equal to its inverse is unitary matrix. Therefore, it satisfies the definition. So the given problem is a unitary matrix satisfied. What is unitary matrix and their properties? A unitary matrix is a complex square matrix whose columns and rows are orthonormal. It has the remarkable property that its inverse is equal to its conjugate transpose. A unitary matrix whose entries are all real numbers is said to be orthogonal. So A star A is nothing but 1 by root 2 minus 1 by root 2 I, 1 by root 2, 1 by root 2 I. Into 1 by root 2, 1 by root 2, 1 by root 2 I minus 1 by root 2 I. So 1 by root 2 into 1 by root 2 minus 1 by root 2 I into 1 by root 2 I, 1 by root 2, 1 by root 2 minus 1 by root 2 I into minus 1 by root 2 I. 1 by root 2 into 1 by root 2 plus 1 by root 2 I into 1 by root 2 I, 1 by root 2 into 1 by root 2 plus 1 by root 2 I into minus 1 by root 2 I. We'll get 1 by 2 minus 1 by 2 I square, 1 by 2 plus 1 by 2 I square, 1 by 2 plus 1 by 2 I square, 1 by 2 minus 1 by 2 I square. We'll get 1, 0, 0, 1. So this is nothing but an identity matrix. Our unitary matrices are reversible, mathematically reversible. Transformations are performed under unitary matrices. H is equal to 1 by root 2 into 1, 1, 1 minus 1. H star is equal to 1 by root 2 into 1, 1, 1 minus 1. So H into H plus is equal to 1 by root 2 into 1 by into 1, 1 minus 1 into 1 by root 2 into 1, 1, 1 minus 1. Then we'll get 1 by 2 plus 1 by 2, 1 by 2 minus 1 by 2, 1 by 2 minus 1 by 2, 1 by 2 plus 1 by 2. We'll get 1, 0, 0, 1 and identity matrix 1. A unitary matrix is orthogonal. A square matrix is called a unitary matrix if its conjugate transpose is also its inverse. So basically, the unitary matrix is also an orthogonal matrix in linear algebra. So we can say that a unitary matrix is also an orthogonal matrix in linear algebra. As a square matrix is called a unitary matrix if its conjugate transpose is equal to its inverse. So are all unitary matrices normal? Unitary matrices are normal. Remember that a matrix is unitary if its inverse is equal to its conjugate transpose. A star A is equal to I minus 2 minus 3i, 2 minus 3i into minus I minus 2 plus 2 plus 3i minus 2 plus 3i 0. On multiplication, we'll get minus I square plus 4 minus 9i square, 2i plus 3i square minus 2i plus 3i square, 4 minus 9i square. We'll get 14 minus 3 plus 2i minus 3 minus 2i, 13. So, is unitary matrix a symmetric matrix? A unitary matrix U is a product of symmetric matrix. Unitary matrix of the form EIS where S is real symmetric and an orthogonal matrix O. That is U is equal to EISO. It is also true that U is equal to O EIS where O is orthogonal, S is real and S is real symmetric. Can a unitary matrix be singular? The singular vectors are not unique. The singular subspaces associated with the singular value are unique. As such, for unitary A, there is one singular subspace consisting of all vectors. And singular value decomposition can be constructed by an unitary matrix whose columns will form a basis for this space. Can unitary matrix be diagonalized? A matrix A is diagonalizable with the unitary matrix if and only if A is normal. The diagonalizable of with a matrix A is diagonalizable with a unitary matrix if and only if A is normal. In other words, if A is normal, there is a unitary matrix S, so that S star AS is diagonal. B, if there is a unitary matrix S, so that S star AS is diagonal, then A is normal. Sorry, excuse me. Sorry. So the main formula of unitary matrix is nothing but the conjugate transpose of a square matrix is equal to its inverse. So U inverse is equal to UH. Here H is nothing but conjugate transpose of a square matrix. So this is the main formula of a unitary matrix. Unitary matrix. Unitary matrix. All the columns and rows form orthogonal basis. It can be proved via definition. Linear independent rows or columns. We have that det A not equal to 0. U is unitary if and only if the length of det of ux is same as the length of det of x. Det of ux whole square is equal to ux power h, u power h, ux is equal to x power h, x is equal to det x whole square. So unitary matrix definition. A matrix A is called unitary if A inverse is equal to A conjugate transpose. So star is conjugate and D transpose. The conjugate transpose of a square matrix is equal to its inverse is nothing but a unitary matrix. So example, A is equal to 1 by root 2 into 1, 1 minus 1, 1. So A inverse is equal to 1 by root 2 into 1 minus 1, 1, 1 is equal to A transpose. Note, transpose and conjugate can exchange, that is A star T is equal to A T star. Nothing but star is transpose, sorry, conjugate and T is transpose. For a real matrix A, it is unitary if A inverse is equal to A transpose. So, and it is an example of a 2 by 2 unitary matrix. The matrix E is equal to 1 plus I by 2, 1 plus I by 2, 1 minus I by 2, minus 1 plus I by 2 has row vectors. So R1 is equal to 1 plus I by 2, comma 1 plus I by 2. R2 is equal to 1 minus I by 2, comma minus 1 plus I by 2. So mod R1 is nothing but root over 1 plus I1 by 2 whole square plus get 1 plus I by 2 whole square. We'll get 1 by 2, root over 1 by 2 plus 1 by 2 will get root 1 nothing but 1. So R2 is equal to root over 1 minus I by 2 whole square plus minus 1 plus I by 2 whole square is equal to root over 1 by 2 plus 1 by 2 is equal to 1. On multiplying R1 into R2 is equal to 1 plus I by 2 into 1 plus I by 2 whole bar plus 1 plus I by 2 into minus 1 plus I by 2 whole bar. We'll get 1 plus I by 2 into 1 plus I by 2 plus 1 plus I by 2 into minus 1 minus I by 2 is equal to 0. So this is an example of a 2 by 2 unitary matrix. So yeah, thank you. This is the unitary matrix concept video on maths. Nothing but the definition of unitary matrix is the conjugate transpose of a square matrix is equal to its inverse is nothing but a unitary matrix. So yeah, this is the concept video of a unitary matrix maths. Thank you.